So we have H2PO4 minus, and we have HPO4 2 minus. Before we look at the question, what is the difference between these two ions?
Say repeat.
What is the difference between these two ions?
One has an additional hydrogen.
All right. So which one would be the acid?
The
H2PO4.
first one.
Right. So this would get converted to this plus H plus. So before even looking at the question, how would this act as a how would this act as a buffer? So remember, with a buffer, when we add OH or H plus, this should be able to counteract the change. So what would happen if you add hydrogen ions to this buffer?
It will shift to the left to reduce the amount of concentration of hydrogen.
Right. So HPO2 minus would accept a proton to form this. And then if what would happen if you add OH ions to the buffer? How do you get rid of the OH ions?
You would have bonded the H plus
All right. Anything else?
and form water.
All right. For me personally, there was an answer booklet. The answer they give is to bond with H plus. But if we know about buffers, right, it's a weak acid, so you won't have much H plus in there. So for me, this is the acid, this is the base. You will have a lot of these in the reaction. So this could accept a proton from this. So it's not that you would be increasing the H plus. This would accept a proton and form water. If you remember with the carbox, the ethanoic acid buffers that we did in class. When you get this right, hold on, CH3COO minus plus H plus, right? When you add OH, when you add OH ions to the buffer, how do we get rid of the OH? Yeah, correct. It could react with some of the hydrogen, right? But not a lot of hydrogen will be there because it's a weak acid, right? So most of it will react with this, so it would accept a proton, all right?
But sir,
Sir,
isn't
I
there
wasn't.
of the buffer system?
Hmm?
Isn't there
Wait,
another part?
sorry.
Oh,
Hmm?
isn't there another part of the buffer system where you'd have, for example, HCO4 Na, which would dissociate to give HPO2 minus plus Na, and then you'd have a lot of the base.
Right, you would have a lot of the right the neck, but you see this ion is for the acid. So right, so like in this one, right, where you have the CH3COO minus. So if you remember, a buffer is made from a weak acid and its salt. So you would have a lot of this ion coming from the salt, but this ion is going to deal with the addition of acid. So you see this negative ion coming from the salt, right? So most of this ion is not from the acid, it's from the salt. Example, sodium ethanoate. So a buffer is made from a weak acid and its salt.
Sir,
So most of, yes,
Is
Go ahead.
is the salt also conjugate base?
You could look at it like that in that sense, but
Okay.
conjugate base normally have to do with the acid. But yeah, it would be the same ion that is the conjugate base. Yeah. So
Okay.
most of this ion is coming from the salt because the salt is soluble. So remember, weak acid, it partially dissociates. So you only get a few of these from the acid, but you get a lot of this ion from the salt. That is why I'm saying you will not have a lot of hydrogen ions in your buffer. You will have a few hydrogen ions. You will have a lot of your weak acid molecules. You will have a lot of this ion, but it's from the salt, not from the acid. So in this question now, I'm saying that you would not have a lot of hydrogen ions, all right? Although this buffer is in the body, so maybe that will be different. But generally, if this is the buffer, you will not have a lot of hydrogen ion. Based on this equation, this is a weak acid, right? So when you add H plus, right, this negative ion will accept the proton. So you get, so the equilibrium shifts to the left. And then if you add the base, right, the base can react with this to form water. That is correct, that is a reaction. But not a lot of H plus would be in there. So it should be able to accept, this is an acid, this is a base. So if it accepts a proton, it will tilt the equilibrium to the right, where you get HPO4 2 minus. But you would not be getting the H plus, because remember, this will be accepting a hydrogen to form H2O. All right. So I would use this as well as the H plus to account for the in to to facilitate the removal of the excess OH ion. All right. This was just a quick recap. So let's answer the question now. Just remember, to make a buffer, you need a weak acid and its salt. That's for an acidic buffer. For a basic buffer, what do we need for a
A weak
basic
base and a salt.
And the
weak
salt.
base and its salt? Right. So it says using the buffer system mentioned above, describe how this solution maintains an almost constant pH. All right. So you just use the equation. So H2PO4 to give HPO4 2 minus plus H plus. So what you would tell them, right? You're going to tell them that when you add the hydrogen ion, the reverse reaction will happen, which is H plus HPO4 2 minus to give H2PO4. So what we are doing, right? Remember, buffer must resist change in pH. If you add excess to the buffer, it is going to get more acidic, so the pH is going to drop. So to prevent that, the buffer must get rid of the excess hydrogen ion. So because a lot of these ions are there, it will combine with the hydrogen ion. So it will shift the equilibrium to the left. All right. And you can show them this reaction. This is how we get rid of the hydrogen ion. It combines with this ion to form this. And so the equilibrium will shift to the left hand side. You are getting H2PO4. When you add hydroxide ion, it can combine with the hydrogen ion to form water. Alright. But I will check. But my answer here, but this is a definite acid, so it should react as well with the hydrogen ion to give you water. Right? No, you will not get, as I said, it will not increase the hydrogen ion concentration because the hydrogen is going to form water. Wait, sorry, not hydrogen ion, hydroxide ion. So the hydroxide ion would accept a hydrogen ion to form water plus HPO4 2 minus. So all you need to do, right, is show them how you can get rid of whatever you add. So if you add H plus, it combine with this ion. And if you add OH minus, it can combine with the hydrogen ion that is there. Or it can accept a proton from the acid that is there. All right. So to form water. So in explaining these, use your equations. All right. Yeah.
Sir, I can do another buffers question.
Yeah. Afterwards, I email myself too. All right. Calculate the pH of a soft drink in which the major buffer ingredients are 6.5 gram of sodium. What is this? Phosphate, I think. But I'm not going to call it. Right. So we have the two compounds. All right, and 8 gram of this compound. Now remember, if you look at the equation, it was H2PO. What was it again? H2. Wait. H2PO. No, it should have some charge on it. H2PO4 minus. All right. H2PO4 minus to give HPO4 2 minus plus H plus. Now, if we're doing a calculation, we would use H plus squared. But remember now, for a buffer, these two are not going to be equal. The reason being, when we do buffer calculation, right, this ion is coming from the salt, or most of it is coming from the salt. So you get some from the acid, but most of it is coming from the salt. The hydrogen ion is only coming from the acid. So when it gets to buffer, these two are not equal. So Ka, so you're still going to use Ka, but this time you're going to say HPO4 2 minus. So you're not using H plus squared. All right. Divided by H2PO4 2 minus. No. H2PO4 minus. Why am I have plus there? So I move too fast. All right. H2PO4 minus. Right. Now, so if you want H plus, if you don't understand this transposing, you let me know. But H plus will end up be equal into, so this times this, so K will end up be equal into Ka times
Pure
H2PO4
4 minus
minus, right,
over
divided by,
H2.
right. No, normally they would give you the concentration in moles per dm cube already, but
Wait,
they want to
sir.
be this. Hmm?
Sir, at times both sides by the. Yeah.
So you would cross multiply. So this come over here and Ka times this come here. So if you want hydrogen by itself, you would
Oh,
divide
divide.
by this, right?
Alright, sir.
Yeah. Where's it? I had worked out this already. No, I don't have the paper with me. All right, so let me try to do this back quickly. So we need to find the mole and then the concentration. So mole is mass over molar mass. So it would be 6.5. So I'm working out this one. So it would be 6.5 divided by, let me do this quickly. All right, so done. Let me just, I think I have the answer somewhere. Give me a second. Save some time. All right, yes, so mm, da, da, da. No, this is of no help. I have to work it out. All right. And so sodium is, so that's 23 plus 2, 25 plus 31 plus 64. All right, somebody just work out this for me. 6.5 divided by 120. And then the next one, no, it would be 8 divided by, all right, that would be 46 plus 1 plus
Zero point
31
zero five four for the first one.
plus 6. All right, just a second, plus 64. So this would be 142. Please repeat the answer now.
0.054.
0.054. And then you're going to divide it now because you have to get the concentration. You're going to divide it by 0.355 dm cube. So remember, concentration is mole over volume. All right, so let me do the
Zero
8
point one five two.
divided by 1. Just a second. This is 0.056 divided by 0.355. All right, how much I got for this one now?
0.152.
0.158.
52.
Oh, 0.152. All right, and how much I got for this one?
0.157.
Well, I think
Or
this
zero
should be.
point one five eight.
All right, so we
0.158,
can
yeah.
go ahead now and plug them into the equation. So Ka is 6.4 times 10 to the minus 8 times, this one was the H2PO4. All right. All right, so it's 6.8 times 0.152 divided by 0.158. All right, that would be equal to 6.4 expo negative 8
I get 6.15 or 6.16.
times 10 to the, when you're dealing with these big numbers, pay attention to the right hand side of your calculator. Sorry.
Yes, sir. Times 10 to
So,
negative 8.
right. So when you're working with very tiny numbers or very big numbers, just pay attention to the end of your calculator screen for a times 10. All right. Yeah. All right. So this is the hydrogen ion concentration. All right. So after that, now, then we can calculate pH. So pH is equal to negative log 6.16 times 10 to the minus 8. And that would be equal to 7.2. Right? And that is how you do buffer calculation. And I'm
So
going
you
to,
can zoom out, you
yes,
can take a screenshot.
oh, yeah. Give me a second. Let me just do that now. Yeah. I can zoom